Welcome to the second section of this course. After getting the basics out of the way, it's time to make a study of functional programming. Functional programming has slowly made its way into modern development with languages like Erlang, but JavaScript always had functional principles built right into it. More and more people are witnessing the benefits of functional programming, and whether you plan on going full functional or not, some of its features come in handy when writing cleaner code. Just incorporating a few functional principles to your coding style will result in great benefits regarding code cleanness and readability. We will begin this section with a theoretical introduction to functional programming. After that, we will write our first pure function. Later, we will see how we can avoid mutating state by creating copies of objects with the object.assign method and the spread operator. Moving on, we will use several methods on arrays that operate the functional way and compare them with traditional solutions to the same problems. This video will be just theory. We will examine the fundamentals of functional programming in case you've never heard about it before. Even if you haven't heard about it though, chances are you have applied some of its principles without even knowing it. In this video, you will learn what functional programming is, and you will get to understand a few of the most common terms associated with functional programming, like pure functions, immutability, and side effects. The truth is that if you search the internet, you will find multiple academic definitions of what functional programming is, and it's very easy to become confused and discard it as something that is hard and pointless. So I tried to invent a short starting definition. You have to understand that this is by no means a complete definition. This is one that I personally find to be the easiest for newcomers to understand. Functional programming is a declarative style of programming that has three major principles: pure functions, avoiding side effects, and avoiding shared state. Let's examine those three in isolation. Let's begin with pure functions. A pure function is simply a function that, given the same input, will always have the same outcome, the same return value. That means that the results aren't somehow manipulated by a changing internal state. A pure function has no side effects. That's it. That's the definition of a pure function. But what is a side effect? It's when a function modifies the application state in a way different than its return value. A pure function accepts some input and produces a return value. If that function affects the application state in some other way, like changing the value of an argument passed by reference, printing something, or changing a global or shared field, then those changes are considered side effects and the function is no longer pure. This function, for example, accepts two numbers and returns their sum. It does not in any way affect shared state, and the results of its actions are only visible by inspecting the return value. So this function is pure. Now take a look at this function. This function mutates the internal class state by storing the result of the addition to a variable potentially used by some other method in the class. This is a side effect, and therefore the function is not pure. Finally, let's clear up what we mean by shared state, the third principle upon which I based my functional programming definition earlier. Shared state can be anything that is shared among two or more functions, but in JavaScript, shared state is created by classes. All fields in a class are part of a shared state, and if a method changes their values in any way, that is creating side effects, like in the previous example. Global variables are also shared state, and so is anything that comes with closures. The last one can be a bit harder to understand, but if you pass a variable by reference from one function to another, then you are creating shared state because both functions are able to edit the same variable. In this first video, I decided to keep things simple in order to avoid scientific jargon. If you've never heard about functional programming before, I hope you got a nice and friendly introduction from this video.